Hey folks, I wanted to film this video about where things are at right now with natural language queries for quantitative data. So with generative AI, everyone I talk to, every company wants to be able to have natural language interface over their knowledge base. We see generative AI, we see ChatGPT, and we want to be able to put our own data in there and be able to search over it and analyze it without having to learn a bunch of specialized Excel macros or SQL language or anything like that. And we are almost there, but not quite. I think that this is something that will be really robust and possible in the next 6 months to a year, but isn't quite there right now. And I'll give a demonstration on why. Lots of people have tried things like Code Interpreter and ChatGPT, or created demos with Llama Index, and that's what we're going to show today. And it's really exciting and it's really powerful. And I am personally very excited about the leaps and bounds we are making there. But there are a couple of things to consider that make this specific use case of having a data set that is not in natural language and talking to it in natural language, um, that make it a bit harder and that make the quality that we have right now very unuseful. So this is for a few reasons. One, generative AI models are naturally stochastic. They're different every time. And this is wonderful. This is what makes them different from every other software ever created. There are tricks that you can make in terms of making them more deterministic. In the case of image generation, you can fix the random seed. A common mistake that developers make with natural language, with LLMs, is putting the temperature to 0 to make it deterministic. This makes the language much worse. It makes the language more boring and rote. It has a demonstrable effect on the quality of the outputs for the user. So you solve the engineering problem, but you hurt the user in the process. So also, it's just not what LLMs naturally want to do. It's not what generative AI is good for. Generative AI is good at being different every time. However, quantitative analysis needs to have the same answer every time, or at least the outcome must be the same, even if the process of getting there can have some differentiation. If you're asking for a percentage of a data set that is of a certain category, that percentage needs to come out the same every time, even if you can have some variations in the computation. And this makes it difficult to use stochastic principles in order to get there, because you have to have this exactly right batch of stochastic versus non-stochastic, guardrail versus non-guardrail, to get the right answer every time, without any mistakes. And I do mean without any mistakes. And this is kind of the biggest factor here, in my opinion, is that for quantitative analysis, the bar for precision is much higher. And I do mean precision, not accuracy. For qualitative writing, the bar for accuracy is very, very high as well. However, the precision that you need in quantitative analysis is several nines past 99%. If I have a blog that is 90% correct, or 90% blog, so to speak, this is useful. But if a calculator is 98% correct, or only correct 98% of the time, this is 150% useless. A calculator only becomes useful at the point at which I can rely on its calculation without having to do the operation manually afterward in order to do it myself. So there's a difference in quantitative analysis that means that it has to get a lot better, much better than the bar for qualitative writing and natural language than what we have, even if they're at the same level of ability right now. However, even though this is very hard, everyone wants this. Every company wants this and could use it. And so there's tons of investment and effort pouring into it. And there's definitely features that involve this kind of thing that you should be putting on your roadmap for the next 6 to 12 months from now, as these things get better, as people work on them, come out with new tools and new methods. Some of this is at the level of the language model. Language models get more and more robust, are able to perform these kinds of translations more and more reliably, as well as methods outside of the model, different forms of retrieval and context injection and patterns, that allow us to replicably produce results at a level of reliability that they become truly automated and useful to the user. Okay, but so today I want to show you what the limits are today. And I'm going to do this in a tool called Llama Index, or a coding framework. And the idea behind Llama Index is that you can take multiple forms of data, both quantitative and qualitative, both natural language and tabular, and put them kind of in the same library, or organize them with an orchestration layer above it that then decides which to use depending on the user query. So the idea is, in our case here, what we have is we have both some Wikipedia articles about game publishing and different video games, along with some tabular data, a toy data set that we pulled about game sales. And I'll show you a little bit what that looks like. Then we're going to go down and we're going to use the Llama tool in order to ask natural language questions to our data and see what we get back. And I think this is really magical. The extent to which it's right, I think, is just so compelling and brings me a lot of joy and excitement as someone who doesn't particularly like tabular data analysis and doesn't feel particularly good at it. However, there's some hard edges to it where it starts to get things wrong. And like I said, the places where this is wrong are more severe because of the type of data we're dealing with, type of calculations. Thanks to Ekamini Mendy for his help putting together this notebook as well. So up here, we're just setting things up. We put in our OpenAI key, and we set up a Pinecone vector database, which is a way to kind of store the different parts of our data in an easily accessible way. And then we pulled the data set, which is these video game sales, just a kind of open source toy data set. And honestly, for this demo, it doesn't really matter what's in here. Made some small modifications to the data set to make it easier to work with, took out some nans and some things like that. You can see put in some underbars. So this is what it looked like. We have the game title here, and then we have the platform that it was on, and then we have the year, and the genre, publisher, and then the different places that the game was sold with the numbers of sales, and then the percentage of the review. And so we're going to set up a SQL database here. And I went through and did all this already so that you didn't have to watch it spinning. If you want this notebook to play with yourself, feel free to reach out and I can DM that to you. Set up the SQL database and just put in our data and do some checks to make sure everything's coming out all right. And see that we can do SQL operations over it. And then we put in our different types of natural language wiki docs, these some on publishers, some on game consoles, and the different games. That's actually not super important for this demo, but it's just nice that you have that. Then we're going to set up our Llama index, and you can see you can actually define here. This is kind of interesting. This is where you describe which parts of your data are good for what. And this is what GPT-4 then uses to kind of decide which data source it should use to answer the question, or whether it should use both. And I think this is just frankly really beautiful, and I'm so excited about it. And I think in 6 months to a year, this is going to, Llama Index or orchestration tools like it are going to be a part of essentially any kind of software. It's just so obvious once you start working with it. And so I'm going to now make some queries, some questions over my two kinds of data, with an emphasis on the quantitative data. And I've spoiler alert, I've tried all these questions in advance, so I know it's going to happen. And I want to do some to show you at first how powerful this is, and some of the ways in which I think that this is amazing, and then show you some of the edges and discuss why these are an issue. and then what might happen over the next 6 to 12 months that would make this work better. So I can come in here and I can ask, so in natural language, which publisher made the most games in the last 5 years? And you can see as it's thinking about it, it actually will show us its work. And so it decides and tells us why it's deciding that it's going to query the SQL database because it wants to find these specific things. And you see it generates all the SQL, access the SQL database, and then gives us the response that Nintendo made the most games in the last 5 years with a total of 22 games. So I did go back and check on this, and that number is correct. So that's awesome. And then, so I want to try and see if it works with different kinds of syntax, language syntax that are a little bit more obvious. So I instead ask it which publisher was the most prolific in the last 5 years. And what I'm trying to do here is model what a user would do. And this is part of the thing with generative AI is that when you have natural language inputs, users are going to do all kinds of stuff, and you have very little control over what your users are going to put in, and it's hard to constrain them. So these should match, and as we can see, it does match. Okay, so it said 5 years with 22 games. Again, we get the same answer, which is correct. So if that is true, then that means that if we ask which publisher sold more games than Nintendo in the last 5 years, we should get the correct answer would be that no one has published more games than Nintendo. And so again, it's choosing to access the SQL database. And we can see that there is no publisher that sold more games than Nintendo in the last 5 years. This is pretty cool. So we have consistent responses, we have different kinds of phrasing, and it's able to take in all of these and access a quantitative database to perform the operation correctly. So I thought, okay, what's a more challenging way to think about this? The Wii has games that are made by Nintendo and others. So without calling out specifically, using some language that might be hard for it, like third party, because we can see in our database up here, if we scroll up, that it doesn't say third party here anywhere, right? So it would have to like intuit essentially what that would be. And in fact, it does do that. And you can see that it adds into the SQL where platform equals Wii and publisher not is Nintendo. I'm amazed by this. This is really a lot of reasoning that it's doing in order to perform the computation. And then so again, check for consistency. This should then be consistent with what publisher sold the most games on Wii besides Nintendo. This is actually the same question with different phrasing. And we can see that as it comes out, it generates a slightly different way of getting there, but it also gets to the right answer. And so I actually wanted to check on this. It says final response, the publisher that sold the most game is Ubisoft with 31.45 million. Although this looked consistent, I wanted to come down here and actually check the actual SQL database to see if this smelled right. And as you can see, Ubisoft did produce most of the third-party games overall. And so this looks consistent with the real data. Let me pause here because this is really powerful. And this ability for a uninformed user to access data in this way without any knowledge of Excel macros or SQL language or anything like that is really cool. However, there's some edges too. And so I want to go over some of these. So it started to run into trouble when I started asking about the different regions. So we can see that up here in our data set, there's these different, it's broken out by region: North America, Europe, Japan, rest of world, and global, which is a sum of those. And so I can come in here, and when I ask who sold the most outside of the US, it generates the SQL, and the SQL is all fine. But if I look at this, we can see that it says select publisher and rest of world, and then it selects the top from rest of world. Now, this is not correct because rest of world does not represent everything outside of North America. Rest of world represents everything outside of North America, Europe, and Japan. And so this is not correct. And I know this because I know how the data set is structured. So I thought maybe that's a little bit tricky for it. Let me try something easier and ask who sold the most outside of North America. And we'll see that although it is consistently wrong. It again gives me the same answer looking at only the rest of world column. Now, let me reiterate my initial point. In the case of qualitative responses from generative AI, this kind of mistake is generally fine, and is actually can be useful because you are able to surface this to an untechnical user who then can work with it and modify it as they need. The problem here is that, but we do get these same hallucination problems with qualitative data, and they can even be a problem. The problem here is that I only know this is wrong because I already know the data set in advance. And if you are surfacing this to a user, you don't want the user to have to know what the data set structure looks like in advance for them to be able to use this tool. And if I can't trust it to be able to do the computations right every time, then it fails in its ability to be useful in a quantitative setting. This is a difference between qualitative and quantitative, that imprecise responses, getting it wrong basically ever, for users that don't know a lot about the data set, has just a much higher cost in this setting. It continues to get things wrong if I ask which publisher sold the most games in Europe. Sorry, it will get it right if I ask sold the most total games in Europe. I'm asking it something that I know is in the data set. This number is correct. It also gets it right if I ask what are Nintendo's total game sales again. But then if I ask how many games did Nintendo sell outside of Europe, it also will fail. And I know that it failed without checking the data set because I can see this number of the total game sales, and I should be able to just subtract this number. And that number certainly should not equal 0. And I know that this is not the case from the data set. And so let's try one last one. How many consoles were sold for the top selling console? The data set contains nothing about console sales. It is only a game sales data set. However, despite this, it tries to calculate it, and it tries to sum all of the global game sales to give me an answer, which of course can't be correct because there's no data about console sales. So again, my point here is not to cherry pick situations in which on this system, Llama Index gets it wrong. I'm not throwing rocks at Llama Index here. I think what is important to think about here is the incredible capabilities that this has and how in the next 6 to 12 months, this is gonna get better. As two things happen. One, models will get more capable at performing operations like this through different kinds of fine tuning. And two, we'll have better mechanisms and techniques for getting these more reliable in fine tuning and context injection and things like that. How we feed in parts of our tabular data, how we feed in parts of our qualitative data with prompt engineering for the model in a way that makes it more and more reliable. However, the bar for reliability, again, for quantitative data is much, much higher than for natural language. The bar for precision is higher, although not for accuracy. And I know those of you that are data scientists or working in these systems are going to be saying, you could have architected this so that it got these questions correct. You can fine tune the retriever. You can fine tune the retriever and the generator together on the data set. And I know all of this is true. However, my point here is that with natural language inputs, you don't know what your users are going to put in. And they can put in anything. You think that the things I put in here are off base, and some of these are pretty simple. Things that users are going to put into a natural language interface are going to be way outside what you expected. And it's going to take a really long time to get enough of that information in order to actually be able to effectively fine tune. And that's assuming that your data set isn't dynamic and isn't changing over time, and that the structure is the same, and that the users are the same, which often just isn't going to be the case. And so actually the level of effort that it would take to reliably create a setting in which generative AI is useful for this starts to be constrained enough and starts to be costly enough that you should just put it in Tableau, or you should just put it in Excel, or you should just have a drop down menu that allows them to operate different kinds of data analysis over your data in a constrained way. Because ultimately, that's what you're going to get to is, oh, well, I'm going to choose the top 3 questions, or the top 5 questions, the top 20 questions that I think my users are going to ask. And I'm going to focus on making those really, really reliable. But if you're going to do that, what's the point of the natural language input? If you're going to constrain them to the 20 things, then your users are stuck either just guessing what those 20 things are and getting wrong answers if it's not. So in the meantime, as these things get better, I don't think it's the right time to surface these to users. It is the right time to play with this. Get into Code Interpreter on ChatGPT. If you're comfortable in code, then jump into Llama Index and start playing with it, finding the edges. The next step from here is to start fine-tuning the different parts of this. The different companies that are putting wrappers around this and are getting better all the time. But this is where it is right now. And I thought this would be interesting for context. If you want to know more about this and what is ready to go right now, how to build stuff like this using coding or non-coding tools, what you should be thinking about in terms of investment and development and leading your team on a 6 to 3 year timeline, join our generative AI masterclass at maven.com/handshake, or just reach out if you want to talk about anything with your generative AI ideas with me or our team. We're always happy to help. Thank you, and good luck.